Hi everyone, this is Sharan. Welcome to my channel. Today is the second day since we started NumPy. So the topic that we are going to cover today are indexing, slicing, joining as well as splitting. So to give a brief introduction about what we are going to do later in a whiteboard. So first one, indexing, is to understand how indexing works in a NumPy array. If we want to identify a particular element, as you see in the top here, if we want to pick up an element in the array, or if we want to select a range of values or range of elements in a particular array, like how we can do based on indexing. And the next one is slicing. Let's say we have an larger array. We want to take a small slice of it and maybe do some operations on top of it. So then how we can slice those array. So this will be really useful when we are going to work on image recognition. So where an image would be represented as a pixel. So each pixel will have an information about like RBG, like the color code, and we can use slicing in order to just slice a part of the matrix and to do various operations. So slicing is also popularly used when we have matrix data or data that has been represented in matrix. So the next one is about joining as well as splitting. So let's say we have multiple small arrays. We want to combine them into a single larger one. Then we use join to combine them. And if we would want to do the otherwise, like if we have a larger one and we want to divide it into a smaller arrays, so then we can use a splitting in order to split them into smaller arrays. So these are all the various topics that we are going to see. And so as you see the visual in the whiteboard here, so this is how we are going. This is what we are going to do. But we are going to slightly go into deeper and then see how these work in an one-dimensional, two-dimensional as well as three-dimensional array. Because in real life, like lots of the data that you will be working on will be either two-dimensional or will be three-dimensional. So that's about it for today. Let's get into the tutorial. The fact for today is about water. So it seems that hot or warm water freezes much quicker as compared to water that is already cooler. So I found this concept very interesting. There seems to be a lot of physics behind it. If you are interested, you can maybe search about it and then learn about the physics behind it. Now moving on to the tutorial. So today's session, it's going to be about indexing, slicing, joining as well as splitting of an NumPy array. So in case of join, we are going to use how to use concatenation as well as how to use a stack functionality in order to join two or more arrays. And let's get into the details. So in order to use all these functionalities, of course, we need to import the NumPy package. So the first command is importing the NumPy package. If you have any issues here, like it's mostly because like your NumPy package is not installed correctly. You might have to do a pip install and restart Jupyter Notebook to get started. So now what I'm going to do is I'm going to create three different arrays with 1 dimension, 2 dimension and 3 dimensions. I'm not going to go into the details of how these arrays are created. It's already been covered in the previous session. We are going to use reshape in order to create the array as per our requirement. So I'm going to just execute them and then create all those three arrays. So as you see, the first one is one dimensional. It has about 20 elements. So second one is it has the same 20 elements, but it is divided into 2 rows and 2 dimension. And third one is still the same elements, like 20 elements in total, but we have 2 arrays and with each one with 2 rows and 5 columns, hence 3-dimensional. So what we are going to do is we are going to see how indexing would work in case of all these cases, like 1-dimensional, 2-dimensional and 3-dimensional arrays. So indexing is mostly used to know like how to pick up an element based on its location. So let me just print this particular array. So what we are doing here is we are just printing the array 1, which is 1-dimensional, and in order to pick up the element that is present in the third position from the beginning, we need to use index of 2, because as we know, index starts with 0. So index of 2 picks up the element that is in third position, which is nothing but 2. So that's what we see here. So if in case we are going to work on an 2-dimensional array, So then we need to pass on like two elements as input, like which row as well as which element. So let me execute this, and what happens here is we are interested in the fifth element on the second dimension. So here so this is the column, so which would be, in order to get the fifth column, we pass on the index as 4, and the second dimension is the first, like we have two rows here. So second dimension is we are saying that it should be of index 1, which means that we are going to pick up the second row. So the fifth element on the second dimension is nothing but 14. So if we see, the position is 1, 2, 3, 4, and if it's fifth position, and it's the second row. So that's how we pick up an value from a two-dimensional array. And similar thing is for an three-dimensional array. We have to pass three values to it, like which layer and which dimensions, as well as like which element that needs to be picked up. So as I execute this, like in order to get fifth element, of course it should be of index 4, and second dimension, which should be 1, because like it starts with 0, and from the first array. So first array will be this, so this will be represented as 0, and second array will be represented as 1. And after going to the first array, which is 0, in order to get the second row, we have passed on the value 1, so it goes on to this particular row. And when we say number 4, so it is the fifth element, which is value number 9. So that's been picked up and displayed here. So that's how indexing would work. So it's really important to understand how indexing is working in case of matrix, like especially when we go on to the higher dimension, like a 2, 3, or like higher dimension, it might be slightly confusing. So maybe try to repeat this with new sets of data, and try to predict like which is the element that you want to pick, and maybe try to codify it using Python, and see if you are able to correctly identify the elements like as per your expectation. So this would help in better understanding the array, like how they are being stored and how we can access them. So which will be definitely useful as we go into the details of the algorithms, or into the implementation. And finally, regarding the negative indexing, just to know what happens when you give a negative index. So here what happens is, this is a two-dimensional array. So we want to pick up the last element from the second dimension, like the last element from this row, which is 19. So we give the value as 1. And when we give -1, it means that, as very similar to what we have covered in pandas, when we do minus or -1, it means that it's the last element. So when we give -2, it will be the last but one element, and so on. So essentially, when we start with the negative, it starts with the last element and comes back. So that's how indexing would work in the NumPy package using Python. So next one we are going to do, we are going to see how slicing works. So slicing, as I explained, is important if we want to slice a part of an array and maybe use it for an operation. So we are going to see how slicing works in case of one-dimension and two-dimensional array. So here we have an one-dimensional array. So let me execute it. So what happens is, in this one-dimensional array, when I simply use array and :7, it picks up the value until just before the index 7. So the index 7 would be so the index starts with 0, so same as these elements. So the index 7 would be somewhere here. So when we give a range as up to index 7, what happens is it prints one, like it goes up to the element 1 before the index. So it stops here, and then it prints only these elements. So that's what you see here. So in case of two-dimensional array, we need to pass on two parameters. So here what we are saying is, we are saying in the first row, we are interested in the elements from index 1 to index 4 position. So this is the first row, and index 1 will be here. So index 1 to index 4 means that it will stop just one element before the last element that we have specified. So it prints up 1, 2 as well as 3. It doesn't print the last element that we are specifying it here. So it prints just one element before it, or it goes up to one element before the last value that we are specifying. So in case we want to slice, here what we are doing is we are slicing an one dimensional array from a two dimensional array. So the original array is 2 dimensions. We are just slicing a bit of it which is of 1 dimension. So let's say we want to slice we want to keep the dimension, we want to keep the 2 dimensions and then select maybe a set of elements from both the dimensions. So then what happens is, if then we need to pass on pass on the additional parameters. So here when I execute this, what happens is it says both the dimensions needs to be picked up, and from both the dimensions the elements from the index 1 to up to index 3. When we mention it as 4, it stops at 3. So what happens is it prints up 1, 2, 3, as well as in the second dimension 11, 12, as well as 13. So that's how we get an sliced 2-dimensional array from an original array. So that's how we slice it. So splitting would work slightly different. Maybe when we go into splitting, you will understand it much better. So slicing is pretty much we have a larger array. We just want to slice a piece of it and maybe use it for various operations. So as I explained earlier, so this will be slicing operations will be very useful, especially when we work on the image data, and of course whenever we have an data that can be represented in matrix format, these concepts would be really will be very helpful. So moving on to the next concept, which is concatenation. So let's say we have multiple arrays, we want to combine them and we want to make it as one array. So then of course we can use either concatenation or stacking. We are going to see what's the difference between them, like in terms of implementation. So here what we are doing is I am creating two arrays, like data 1 and data 2. So both of them are NumPy array, and I'm going to use just NumPy concatenate and pass on the two arrays, and then let's see what's going to happen, how the new data would look like. So when I execute this, so as you see here, what's happening is when I just pass on the value as NumPy concatenate, what happens is it prints it takes one array and it joins the other array when it is one dimensional. So what happens is it's still one dimensional, so it doesn't change into 2 dimension, whereas the number of element increases. So the dimension doesn't change, whereas the number of element increases. So that's how it works by default. Now let's say we are going to try the same thing on a 2-dimensional array. Let's see what happens. So here now data 1 as well as data 2 are each 2-dimensional array. So we have the first dimension here and second dimension here, like the first row and second row, and similarly like for data 2 as well. So now when I'm going to do concatenate data 1 comma data 2, let's see what's going to happen. So as you see here, what's happening now when we have a 2-dimensional array is it concatenates, like it takes one array and then it concatenates the other array in the rows. Like what happens is the number of rows increases. So it still remains as 2-dimensional. So what happens is like in the original array we had 2 rows and 5 columns. Now what's happening is we have 4 rows and 5 columns. So number of columns didn't change, whereas the number of rows has increased. Now let's say we want to join an 2-dimensional array but not row wise. Let's say we want to attach it to the columns, we want to increase the number of columns. So then of course what we can do is we can pass on an additional parameter, an optional parameter, and we can mention the axis by which we want to do the join. So when I mention the axis as 1, so what happens is the join would happen on the column. So when I mention like here, maybe, so when I mention here instead of 1, if I pass on 0, so then what would happen is it would be like as the default one. It does the join based on the rows. So that's how like axis can be used, and we can control how the join, like how we concatenate two different arrays. And moving on to the next one, next one is we are going to use stat. So here we are using numpy.concatenate. The next one is we are going to see how numpy.stat would work on. So let's say we are using the same array, like data 1 and data 2 still remain same. I'm going to use numpy np.stat and pass on the two arrays, and then let's see what's going to happen. So here when I use stat, like as compared to concatenate, what happened was by default the concatenation happened by row. So here what happens is it joins it joins the two array, like it stacks one array on top of the other. So this remains as one array and it stacks the other array on top of it. So let me show you. So as you see here, what's happening here is when I use stat in, so the number of dimension doesn't remain same. So here when I execute this particular statement, what's happening is, so it is statting one array on top of the other, or like a one layer and attaching to the other layer. So as you see here, the original array was 2 dimension, it has 2 rows and 5 columns. After statting, what happens is it has increased to 3 dimensions. So we have 2 layers, 2 rows and 5 columns. So when I use the same thing here, let's see what has been happening. So when I execute this one, like as you see here, the number of dimensions didn't change. So it is still 2 dimensional. It has 2 rows and 10 columns. Like of course, number of columns has increased here, whereas in the previous case, the number of rows has increased, but still it was 2 dimensional. But when we use statting, the number of dimensions increases, because what's happening is it is just statting one array on top of the other array. It is not trying to concatenate the elements and then merging it into a single array. That's what concatenation would do, whereas statting is slightly different, where we stat one array on top of the other and then we add a new dimension to the data. So now let's say we want to stat by rows or columns. We want to define how it needs to be done. So then we can use either horizontal stat or vertical stat. So let me just execute this one. So when we mention it as a horizontal stat, so now you can see that it is similar to concatenation, where the elements are being like it now this is one dimension, like now the dimension hasn't changed. So let me just print the dimensions here. So as you see here, now when we use horizontal statting, what happens is the elements of the two arrays are being combined, and it's formed a new array, which doesn't the new array is of same dimension as of the original like individual arrays. So we had an array here which is 2 dimension, and the another array which is again 2 dimension. So when we do an horizontal statting, it is combined into a single array and it still remains 2 dimension, like it has 2 rows and 10 columns when we do the horizontal statting. So let's see what happens when we do vertical statting. So here, like again, the number of dimensions hasn't changed, whereas instead of adding the additional columns, now we are adding the additional rows here. So let me show you what happens to the shape. So when I execute this, so as you see, the number of dimension is still 2. It has now 4 rows and 5 columns, and hence those are all the difference. So by default, when you do statting, like without if you don't use horizontal or vertical statting, what happens is it's been added as a separate layer, and hence the number of like the dimension increases. Whereas when we do horizontal statting or vertical statting, what happens is the dimension doesn't change, whereas it acts as a concatenation operation. So that's about like how to join or how to merge different arrays. So now we will see how to split them. So split them, in order to split an array, we can use array underscore split, and we can specify like into number of pieces that we want to split. So here we have one array, one dimensional array with 6 elements, and then we are saying that this data needs to be splitted into 3 different parts. So now let me show you what's happening here. So when I execute this, what happens is here the original array is being split into 3 parts, like first 2 elements, second 2 elements, and last 2 elements. So this is how the array would be stored. So when I access the new array, the first element of the new array, so when I execute this, as you see, the first 2, like these 2 are coming up here, and so on. So that's how the splitting would work. So we can use array split, and then we can pass on the number of parts that it needs to be split into. So here, depending upon the length of the input value, like as well as like how we want to split, it will be automatically split. Like if if in case we pass on an value which so here in this case it's all equal, like it's divided into three equal parts, but it might not be necessary in all the cases, like depending upon the input as well as depending upon the number of parts that we want to divide, accordingly it will be split. So let me execute this and then a two-dimensional array here, and let's see how it works when we split it into three parts. So as you see here, so this two-dimensional array has about 6 rows and 3 columns. So when I specify it into 3 parts, what's happening is so it's been separated, like the first 2 rows are split into part 1, and the second 2 rows into part 2, and then last 2 rows are into part 3. And so this is how we access the first part or the first portion of the split matrix. So that's about it. So we can also pass on an axis by which it needs to be split. So let's say we want, instead of splitting them horizontally, so here they have split horizontally. Let's say we want to split them vertically. So we can pass on the axis is equal to 1, and then when I execute this, so as you see now it's been split by the columns. So these are all the various functions that can be performed on an array, on a NumPy array. So there isn't any exercise for today as well, but what I would suggest is maybe I would suggest refer online, refer NumPy documentation, and maybe try to go slightly in deeper and then understand what are all the various functionalities, and try to repeat this exercise with different sets of data, and then see you are able to understand how indexing works and how slicing, joining, and how splitting is working in an array. So this might be useful when we go into the algorithms or when we are making any matrix operations on the data. So that's it for today. And if you have learned something new today, give a thumbs up and subscribe to this channel. If you think that this might be useful to anyone, please feel free to share this with any of your friends. Bye for now. See you in the next sessions. Yeah.